Now that we've talked about kind of the definitions of the derivatives, worked with them for a bit, you've solved some problems using the definition, we're going to kind of get to a point where we start using shortcuts, because as you probably by this point you're frustrated using that derivative. The definition, it's long, it's annoying, you have to figure out all these math tricks. So what we end up doing is we just memorize a bunch of these building blocks and rules, and then we can use that to solve more complicated ones. So from this point forward, any of these things that I tell you you're going to want to memorize here, you can use these instead of that definition. So jumping into it, let's look at some of these basic rules. So first we have the power rule. So if you're trying to find the derivative of a function that looks like this, x to the n, and only x to the n, where n is a number, then this is going to be equal to n times x to the n minus 1. So in other words, if you have something like x cubed, then the derivative is going to equal 3x squared. If it was x to the 4/5, then the derivative will be 4/5 x to the negative 1/5, because 4/5 minus 1 will be negative 1/5. So that's what we're going to do here for the power rule. Is just take the denominator, put it in front, and then reduce the, sorry, not the denominator, take the exponent, bring it in front, reduce the exponent by 1. The constant rule, if you have the derivative of a constant, that will always be equal to 0. And that should be kind of self-explanatory, because if you have a constant, it's not changing, therefore the rate of change is going to be 0. The constant multiple rule, d by dx of cx is equal to c. And note that these only work if they look exactly like this. So x to some power, c times x. If it's c times x to some power, it doesn't work. It has to be exactly these forms. Lastly, sum and difference rule, at least for this slide. If you have the derivative of x of f of x plus or minus, so it works for both plus and for minus. This is equal to the derivative of f of x plus or minus the derivative of g of x. So this is nice because it just basically means that you can take the derivative before or after you add the functions. So in some cases, if you know how to find the derivative of the individual functions, you can just split it up, find their derivatives, go forward. So these are all of our basic rules. Now we're going to talk about exponential and logarithmic derivatives. Whoops. So with this, there's a bunch of different ones we can look at. So if we have the derivative of e to the x, that's going to equal e to the x. So this is part of the reason why e is special and important where it comes from. It comes from, well, this and some other things basically where it has this special property that the derivative is always the same as the function. And again, this only works if it's exactly e to the x. If it's e to the 2x, it doesn't work. If it's 2e to the x, it doesn't work. Next, we have the natural logarithms, so d by dx of ln of x. That's going to be 1 over x. And again, that's why e and ln are what they are, because they have these kind of weird, interesting, unique, clean properties here. The general exponential form, so if it's not natural log, it's like log base 10 or log base 20 or whatever. D by dx, or sorry, if it's just the natural or the general exponential, so some other base a to the x, that the derivative of that is a to the x ln of a. And you'll notice this also works for e. If I plug in e, I get e to the x natural log of e, which is 1, so it all kind of cleans up. And there's a similar form for log base A of x. That will equal 1 over x ln of A. So again, if it's log base E, natural log, the ln of E goes to 1, and I end up with 1 over x, which matches what I had before. So those are our exponential and logarithmic derivatives. Again, all of these you just kind of have to memorize if you don't want to have to derive them every time. Trigonometry derivatives. There's a bunch in here, but we'll start with a few of them. The derivative of sine of x is equal to cosine of x. The derivative of cosine of x is negative sine of x. The derivative of tangent of x is equal to cosecant, let me double check, secant squared x. The derivative of cosecant x is equal to negative cosecant x cotangent x. The derivative of secant x is equal to secant of x tangent of x, and the derivative of cotangent of x is equal to negative cosecant x squared. These are ones you'll need to memorize. Definitely sine, cosine, and tangent. Secant, cosecant, and cotangent are useful to have memorized, but we'll see later there is a way to derive them. I'll kind of walk you through that, and you'll be able to see how that works. There's also the arc sine, arc, cosine, etc. And then there's also hyperbolic sines that you might have heard of before, hyperbolic cosines, etc. For all of these, I would just say look them up. Know that they exist, know that you can find them in your textbook, but they're not worth memorizing unless you really have a lot of extra time before the AP exam. So that's what we have for all of our basic building blocks. In the next couple videos, we'll talk about some of the more complex situations.